Hello everyone, welcome to chemistry classes. So in the previous session we have discussed about the measurement of conductivity of electrolytic solution. And we know that the conductance of electrolyte depends upon how many factors? There are so many factors. So in that the leading factors are temperature and concentration of electrolyte as well as nature of electrolyte. As the concentration of electrolyte varies, its conductivity or its resistance also changes. So concentration is nothing but we can express concentration in terms of molarity, molality, normality, like that. So those includes the calculation of number of moles, isn't it? So as number of moles of electrolyte changes, its conductivity and resistance also changes. So better understanding the conductivity or resistance of electrolyte will define one more new term known as molar conductance. The new term is molar conductance, symbolized by lambda m. The symbol of the molar conductance is lambda m. Please remember this. So let us define what is the molar conductance. So it's very simple. The conductance of 1 mole of electrolyte is called as molar conductance. It's simple. The conductance of 1 mole of electrolyte is called as molar conductance, and it's symbolized by m. Its symbol is m. Lambda m. Lambda m is equals to, what is this? Kappa. Kappa divided by C, where kappa is conductivity. Kappa means what? Conductivity. And C is concentration. C means what? Concentration, where kappa is conductivity and C is concentration of the electrolytic solution. And so please remember this is very important formula. By using this formula we are going to solve so many numerical problems. Now the unit of this lambda m is molar conductance. What is the unit? So here let us derive the unit. Here we can derive the unit in two conditions. The first condition, if the concentration is given in terms of mole per liter, because the concentration may be given as mole per liter or it may be given in SI units, mole per cubic meters, isn't it? So lambda m is equals to kappa divided by C, where kappa, what is the unit of kappa? Simon per meter. The unit of kappa is Simon per meter. Now I will take concentration in terms of mole per liter. The concentration in terms of mole per liter. Simon per meter. Here the Simon per meter. The unit of kappa is Simon per meter divided by mole per liter. So I must know that 1 liter is equals to how much? How much? Cubic meters. See here, 1 liter is equals to 10 to the power minus 3 cubic meters. 1 liter is equals to 10 to the power minus 3 cubic meters. So I am just replacing the value of m, liter, in the place of liter, and I will write this value 10 to the power minus 3 cubic meter, 10 to the power minus 3 cubic meter raised to minus 1. So now Simon per meter, say what happens? 10 to the power minus 3 and 10 to the power 10 to the power minus 3 and minus 1. So 10 to the power minus 3 goes to numerator. Now 10 to the power minus 3 goes to numerator. It becomes how much? 10 to the power 3. 10 to the power 3, because 10 to the power minus 3 it is minus 3 raised to minus 1. So it becomes 10 to the power minus 3 becomes denominator of this. So denominator goes to numerator. So I will write Simon per meter into 10 to the power 3, because 10 to the power 3 raised to minus 1 goes to denominator, so it directly goes to numerator. And what remains? 10 to the power m raised to 3 cubic meter into 10 to the power minus 1, so it is 10 to the power minus 3. So finally it becomes 10 to the power 3 means what? 1000 Simon. Here cubic meter and per meter, so cancels out. What remains? Square meter. Simon meter square per mole. So the unit of molar conductivity or molar conductance when the concentration given is mole per liter is 1000 Simon cubic meters, Simon square meter per mole, not cubic, Simon square meter per mole when the concentration is given in terms of mole per liter. And there is another possibility is that the concentration may be given as mole per cubic meter. Mole per cubic meter, because this cubic meter is the SI unit of volume. Okay. So now the lambda m is equals to kappa divided by C. The kappa is Simon per meter. C is what? Mole per cubic meters. Mole per cubic meters. Now what happens here? So here 10 to the power minus 3 it is. So now it cancels out. So what remains? This is per meter and per cubic meter. So cancels. What remains? 10 to the power 2 remains. Sorry, 10 to the power not m raised to 2 remains. Simon per meter square. Simon meter square per mole. Lambda is equal to Simon meter square per mole. So if the concentration of the solution given in terms of mole per cubic meter, now we should use this unit. Lambda m is equals to Simon meter square per mole. So in general, I will write unit for lambda m, Simon meter square per mole, or the sub multiple of this is Simon centimeter square per mole. I can use Simon meter square per mole or Simon centimeter square per mole. So these two are the units of molar conductance. Units of molar conductance. So I can use this or this. So here, so these are the some important conversions. So we should know the conversions. So this is resistivity. Rho means what? Resistivity. 1 ohm meter is equals to 100 ohm centimeters, because 1 meter is equals to 100 meter. So 1 ohm meter is equals to 100 ohm centimeter, and 1 ohm centimeter is equals to 0.01 ohm meter, isn't it? So here, because 1 meter is equals to 100 centimeter. So if I want 1 centimeter, what happens? 100 comes this side. 1 divided by 100 meter is equals to 1 centimeter. So now 1 divided by 100 means what? 0.01. So it is 0.01 ohm meter. So this is for kappa. So these are very much important, because so in the in solving the problems we are going to use them. So the unit of kappa is Simon per meter or Simon per centimeter. 1 Simon per meter is equals to 0.01 Simon per centimeter, and 1 Simon per centimeter is equals to 100 Simon per meter. So just neglect Simon, and just I am converting meter into centimeter and centimeter into meter only. Here also the same thing. So here 1 Simon meter square per mole is equals to 10 to the power 4 Simon centimeter square per mole. So let us see how it is converted. 1 Simon meter square per mole. 1 Simon meter square per mole. So 1 meter is equal to how much centimeter? 1 meter is equal to 100 centimeter. And 100 I will write. So 1 Simon, in the place of meter I will write centimeter. How many centimeter? 100 centimeter square. In the place of meter I have written centimeter per mole, remaining as it is. So 1 Simon 100, I can write 100 as 10 to the power 2 raised to 2 centimeter square per mole, isn't it? So now it becomes 10 to the power 2 raised to 2, 10 to the power 4, 10 to the power 4 Simon centimeter square per mole. So here 1 Simon meter square per mole is equals to 10 to the power 4 Simon centimeter square per mole, isn't it? So next, 1 Simon centimeter square per mole is equal to how much Simon meter square per mole? 1 Simon centimeter square per mole is equals to, so 1 centimeter is equals to how much meters? Here 1 Simon, 1 centimeter is equals to 0.01 meter square per mole. Now 0.01, how we can write 0.01? We can write 0.01 as 10 to the power minus 2. Okay, 10 to the power minus 2 square meter square per mole. Now we can write 10 to the power minus 2 raised to 2, 10 to the power minus 4 Simon meter square per mole. So 1 Simon centimeter square per mole is equals to 10 to the power minus 4 Simon meter square per mole. Okay, so this the conversion of length, you know, 1 meter is equals to 100 centimeter and 1 centimeter is equals to 10 to the power minus 2 or 0.01 meters. And there comes 1 liter is equals to 10 to the power minus 3 cubic meters and 1 cubic meter is equals to 10 to the power 3 liters, isn't it? And 1 mole per liter is equals to 1000 mole per cubic centimeter. So I will write this one also. We'll solve how it is derived. So here 1 mole per liter, 1 mole per liter. So how to write 1 mole per liter? I will write 1 mole divided by liter. So 1 mole per liter I can write directly like this. And so 1 mole divided by liter means what? 1 liter is equals to how much cubic meter? 1 liter is equals to 10 to the power minus 3 cubic meter. 10 to the power minus 3 cubic meter. 10 to the power minus 3 cubic meter. So what I can write? 10 to the power minus 3, if it goes to numerator, 10 to the power plus 3. So 10 to the power 3 mole per mole divided by cubic meter. So what we can write? 10 to the power minus 3 means what? 1000. So cubic meter goes to numerator. What happens? It is mole only directly. So we will write per cubic meters. So 1 mole per liter is equals to 1000 mole per cubic meters. 1000 mole per cubic meters. So if we know the basic conversions, we can convert any of them, isn't it? Okay, so this is about molar conductance and the conversion of the units. We need conversion. Okay, so these are very much important. Please read it again. By using them, we are going to solve some numerical problems. Okay, I hope this video is helpful for you. Please like, comment and share among your friends. Please don't forget to subscribe. Okay, thank you so much for watching.